Welcome, class. This is the first of a three-part series of short videos reviewing some tips and tricks to help you pass the SolidWorks certification CSWA exam. First off, you're going to start off a part creation by making a part. This video is going to cover sketching, and then the second part will cover creating parts, and the third part will cover assemblies. Right after you make the part, the first thing I suggest that you do is to define the unit system you'll be working in. You can do this by going to the option on the bottom right-hand corner of the screen. Currently, I'm in inch, pound, second. Most of the time, you're going to be in either inch, pound, second or millimeter, gram, second. So I'm going to just pull that up, and so you can see these different options. And all you need to do is make sure you select the correct one before you move on to start defining the different aspects of your part. After you have that defined, the next thing that I suggest you do is to define global variables. If the SolidWorks certification exam gives you variables A, B, C, D, those kinds of things, chances are they're going to ask you to change those variables later on. And it's easier to change those in the equation editor than it is to change them by trying to find the sketch where you define them. You do need to be a little bit careful about this, because if you don't do it correctly, or if you don't refer to it quickly, you can run into some issues. So in this case, I'm going to actually define a length, just L, as 10 inches. And you'll note that if I put this in inches, it's going to evaluate it down into millimeters. Typing in the value or the unit of the value for your first set will help you to make sure that you are in the correct units inside your system. So I like to put in a few units just for the first couple of dimensions I put in as a way of reminding myself that I'm in the correct units and that I don't have to worry about that going forward. After you've done it a couple of times, you can ignore it. So in this case, if I did put in 10 inches and then I realized like, hey, wait, I'm in millimeters, I could go back into my unit system, say, okay, wait, I did want to be in inches, I'll change that. And then I can see inside my equations, it's going to evaluate the same thing as I defined. Now, keep in mind that if you want to have mixed units where you want to have certain features in inches and certain features in millimeters, you can do that and leave it the way it is inside the system right now. Although most of the time you want to have it being consistent units across the entire part. So I can change this. So I change that to 10, it's going to evaluate 10 millimeters. It's going to evaluate to whatever units I'm currently in, which is helpful. I also define the width. And also this is equal to 5. And again, I don't suggest defining more global variables than you need, but you can have as many as you want to define your system. Once you've got this defined, go ahead and click OK, and you can start using those inside your sketches. Sketches is the primary focus of the topic for today. So I'm going to start by sketching on the front plane. You might not always want to sketch on the front plane, but if you don't know where to start, I recommend being consistent, just so that way you have a better idea of how your part is going to be oriented once you have the three-dimensional geometry. When you're sketching, you want to decide whether or not the part you're going to be sketching out is part of a boss or a revolve, at least for your very first sketch. We'll cover derived sketches here in a minute. If you're starting with a boss feature, then most of the time you're just drawing whatever the view is on either the kind of the front, top, right view of the part as an outline to start off with, and then adding complexity later on. If you're starting off with a revolve for a part that has kind of polar geometry or revolute geometry, then you want to start by drawing usually a center line that defines where that center of rotation is. So if I want to start with a boss extrude, most of the time I'm going to start with some kind of rectangle or prismatic feature. And I always want to try and orient the origin of my part in the middle of the part, unless you have something that says the origin needs to be in a specific location. This is going to help me because when I go and extrude this into a three-dimensional geometry, especially if I use the mid-plane option, that's going to put the center of my part right in the middle. And so I have all these planes that are kind of crossing across my part by default, and I can use those for things like mirrors and other features later on in the development of that part. So putting that origin in the middle helps you to define the part right off the bat. You always want to make sure that your parts are fully defined. So right now this part is blue. If I add the width, I'm going to say equals to global variables width. Then I can say on the side equals to global variables height. Keep in mind, I am sketching on the front plane. So the length is going to be kind of coming out of the plane in this case. If you don't see that summation signal, you didn't define this correctly. I'm going to do this again. And I don't suggest you follow along this way because you don't want to learn the right or wrong way, but I just want you to see what happens if we don't put the equals. If I just put in H, it's going to resolve, oh, this global variable is H. There you go. It's going to resolve that value, but it's not going to keep the equation that relates that value to the global variable. So in this case, if I were to change the height in my equation editor, it's not going to update because this is no longer linked to that original value. So whenever you're using global variables, make sure you always say equals to, and then specify the variable instead of just specifying the variable. If you don't use the equals to, it won't update when you go and change the values, and it's going to mess you up down the line and kind of eliminate the advantage of using those global variables. So unless you have a very specific case, whenever you use global variables, you always want to make it part of a function using that equal sign. Hopefully that makes sense to you all. Let's go over just real quick some of the different options that we have for different geometry. Each of these tools has a little drop-down menu next to it. The line and center line are going to be your most common tools from this standpoint. The center line is going to be something you want to use whenever you want to make a construction geometry. So something that's not going to be part of the extrude, or when you want to have an axis of revolution. So the center line does not have to be just for center lines. You can use it for, other reference values as well inside your sketch. Most of the time, if you're drawing things out and you're using the line tool, you're just going to freehand the pattern. So whatever it is you want to draw, if I want to draw like an H pattern, I can just freehand that out. And one of the things you want to pay attention to are these yellow and white boxes that are popping up as you're sketching. Those yellow and white boxes tell you what kind of relations are being added as you're drawing. And if it's white, that means that that is a soft relation where it is in that position currently, but it's not actually going to add that relation to the part. The yellow ones are ones that are going to be added to the part. And the yellow ones are the ones that I want you to pay attention to. For instance, in this line here, it gave me the coincident relation that defined this line, if you project it out, goes through this point. If I didn't want that, and again, unless you're looking for it explicitly, you want it, you probably want to leave that out. You want to go through and delete that relation by clicking on it and hitting the delete key before you proceed with the sketch. Whenever you're using the line tool to draw a profile, I always recommend that you end at the same spot you started. If for some reason you can't do that, so for instance, if I'm drawing this around and I want to add some arcs to this as I'm going across, and because of the way I set it up, maybe I have a hard time getting the arc to land where I want it to. Say if I wanted that to come off that bottom piece, but I want it to have some amount of revolution as well. So maybe it needs to come off that arc like a tangent. And I can't get it to connect the way I want to and have it be the shape that I want to. You can always merge it after the fact. So if you can't get your sketches doing a perimeter closed at the start, hold control, click on both of those points and merge them together after the fact. Whenever you're sketching freehand, I always recommend that you draw the entire perimeter of the object that you want to define first, and then start adding dimensions. If you do that, it's going to scale the part to match the size of that first dimension that you add and be less likely to kind of break your part and break the sketch as you're adding more and more dimensions. You have to spend less time kind of fixing and moving things around. If adding a dimension does kind of destroy the geometry of your part and is no longer a closed contour like this one is, don't worry about it. You can just keep adding more dimensions until it's been resolved. So for instance, if I make this really small, that doesn't work out. But if that was the shape that I wanted, I can always just exit the Smart Dimension tool and then drag these lines around until I'm back to where I kind of thought I wanted to be at the start. You may not get the exact sizes that you want right off the bat, but again, as you add more and more geometry to the components, it's going to get closer and closer to the final piece, and you should have to do less kind of modifications of those geometries. So hopefully that makes sense for you all. In the line tool, again, we can quick transition between lines and tangent arcs. So if I'm drawing and I just make an arc with my mouse, it's going to quick movement from the line tool to the tangent arc tool. If that's something that works reasonably well for you, then I suggest using it. It's very helpful. If it doesn't, don't sweat it. I also want to talk about two basic strategies for making parts out inside SolidWorks. The first one is trying to draw the perimeter of the object you're trying to extrude just freehand, like you're doing here using the tangent arcs. The other way is to build up the object from a series of smaller, kind of simpler geometries. So for instance, if I wanted to make that H shape, maybe it's easier for me to draw the boxes themselves rather than the full H. One thing you gotta be very careful about this is you need to keep track where you have overlapping lines. And really, I would suggest you don't use directly overlapping lines if you can avoid it. So for instance, if I'm drawing this box, I'm gonna delete this line to start off with, and I wanna make an H shape, I could draw this by drawing a square and then coming back onto here. I'll start switching to corner rectangle and drawing another box at the bottom, another box at the top. I didn't get that the size I wanted to, but I'll just go ahead and I'll edit it after the fact. Something like that. And then I can trim out the extra lines to make this into a closed contour. Now I've got a single piece. I can also do that without having to worry about the overlap, because that hides those two lines on top of each other. If I start with this outside entirely, then it's a little bit easier to see how I made those parts. And so if you find yourself getting trapped by that, you can always go through and just delete the extra lines with a little bit of extra work inside the power trim without having to worry about accidentally having those overlapping pieces. So sometimes that can be helpful. Again, you can always add relations to the part. So if I hold Control and click on two objects, it's going to give me a list of relations that are appropriate for that. It'll also show me if I have any relations between those two entities already. So I can make these things collinear so that they line up or whatever I need. So line tool, pretty straightforward. Rectangle tool, most of the time you're going to want to use the corner rectangle or the center rectangle. If I'm adding rectangles to an existing part, I'm probably going to use the corner rectangle. If I'm starting off as just making a part and trying to center it inside my workspace, basically center it on the origin, then I'm probably going to use the center rectangle. But again, you don't have to use those, but the fewer tools you can use, the fewer clicks you can do, the faster you're going to be, the more effective you're going to be. To that effect, we should go over some of the other tools that are available to us. We have the slot tool. We can use a straight slot or a center slot. The center point slot is if you want to have symmetry. So if you want your slot to be centered on an object, then you would want to use the center point slot. The 3-point arc and the center point arc slot, again, if you have those geometries inside your part, drawing that out can be very difficult. And all this is going to do is going to draw an arc, and then you're going to thicken that arc with that slot. And getting that geometry by hand can take a lot of time because you have to draw the two arcs, you have to make them concentric, you have to add the arcs on the end, you have to make those are equal and add tangent relations. That takes a lot of time. So if you can use the if you can use the slot tools as opposed to drawing something, that can be very helpful. Circles, again, pretty straightforward. Most of the time you're going to use the center point circle, where you click on the center and then you specify the radius or the diameter of the circle. Perimeter circles can also be nice if you want to have the circle touching multiple spots like that. So again, that can be helpful as well, depending on what you need for your part. Your arc tools, again, center point arc and tangent arc. I don't use the 3-point arc very often, but again, you can use the 3-point arc just like you do with the perimeter circle to get the sides that you want. The tangent arc, again, most of the time you're using that as the quick transition tool from the line tool. And then your center point arc is probably what you're going to use most of the time when you want to manually define what the arc is. So again, just try and intuit what you're trying to do based off of how you're placing your mouse inside here. So just think about kind of where you're going inside this and how you want it to come out. And usually if you just kind of move your mouse around that starting point, you can get it to give you what you want as far as the direction. If you can't get the direction you want, don't worry about it. Just draw the arc and then move it around after the fact. And I think that's a good advice for working in sketches generally. If you can't get things exactly the way you want with your initial button click, try not to sweat it. Try and just figure out what you need to do after the fact to add the relations, add the kind of alignment that you need before you move forward. Hexagon tool, Most of the time I use this for pentagons and hexagons, but you can have any number of sides that you want. Those just end up being the most common shapes. Hexagons are very common for things like nuts and bolts. So if you're drawing something like that, then that can be very helpful to get all those equal relations and make them all evenly spaced so you can get a regular hexagon very quickly without having to draw all of that geometry. So things that you should know from there. Splines and ellipses, you're probably not going to see on CSWA. You might see an ellipse, but really they're sticking with geometry that's fairly straightforward. If you think you need an ellipse, just be real careful that you actually do need an ellipse and that it's not a circle that's being displayed at an angle on a plane, which is much more likely. And then the fillet tool, one real quick important thing I want to talk about with the fillet tool is I generally don't use fillets inside of sketches. And same thing for patterns and mirrors. I prefer to do those inside the features. They're a little easier to manage and they're less likely to break when you change the geometry going forward. Just to give you guys an idea of that, if I have say a center point circle, and then I pattern that as a linear pattern in the sketch, and then I define the diameter of this, you notice that these are still all blue. So the positions of these are still kind of modifiable. That distance that I use for the pattern is not being saved by default inside that tool. And so there is a vulnerability in not getting that spacing really saved the way you want it to, and ending up having things that are not what you want inside the pattern or inside the mirror. So just be careful about that. And if you have the option, I suggest you use the mirror and the pattern tools inside features as opposed to inside the sketch. The other thing I want to note is geometries like this. If you have a corner like that, if the dimension on the height is shown like that, then you probably want to include this arc in the sketch. If the dimension is shown across the entire face, like that, and like that, so this is 3 and 3, then probably you don't want to include that round inside the sketch. You want to include it as a feature on the extruded part. And the reason I say that is because if you need to modify those rounds later, identifying them inside the feature manager is oftentimes easier and more robust than trying to change it inside the sketch, where you may have other things that are dependent upon that cause a relationship that you didn't really want in the first place. Also, if I have the dimensions, like in the previous example, then I really need to have that arc there so I can define the length of that line appropriately. So if you have dimensions like this that go up to the edge of an arc, then you really need to make sure you're including those arcs inside your sketch. Otherwise, I would save it and put it inside the final part. I hope that's a good first intro. Next part, we're going to talk about creating some parts, and then we'll talk about some derived sketches based off of those parts.